All right. We looked at some of the Excel functions. Now we're actually going to do a Monte Carlo simulation. And specifically, I want to show how you can go from a uniform distribution, like using a six-sided dice, and using Monte Carlo simulation, we can quickly prove or show that the central limit theorem holds when you're rolling many die. If you have a six-sided die, the expected value that you get of the mean is 1, 2, 3. You have an equal chance of rolling a 1, 2, a 3, 4, 5, or 6, assuming it's a fair die. There's a 1/6 chance of rolling any of those. And so the expected value that you get, you just add up all the numbers on the die, 1, 2, 3, 4, 5, 6, divided by 6, and you get the expected value, which is 3.5. That makes sense. If the only values I can get are 1, 2, 3, 4, 5, 6, the average value I should get is halfway between 3 and 4, which is 3.5. And then there's some equations for the variance and standard deviation. You can just look these up. I calculated them for you. Like, for the purposes of the experiment, just accept that this is actually the right formula. In real life, if you didn't know the formula, you'd ask. So we're going to look at the variance, and we're going to look at the standard deviation. Okay, so all I'm going to do for the Monte Carlo simulation is I just am going to roll the die 500 times. I have two sets of experiments, actually. I do it one 500 times, and I do one 5,000 times. So remember those rand arrays that we were looking at before? This is where it comes in handy. Okay, so I'm going to go ahead and delete that here. So I can just go rand. If I want to roll a die, a six-sided die, 500 times, I can do rand array, and it asks me for how many rows. I want 500 rows. Asks me for how many columns. One column. The minimum is 1. The maximum is 6. And do I want the numbers to be an integer? It's a die, so it needs to be an integer. And now when I do that, sorry, I actually didn't put the number in. Integer needs to be true. We want to say true for this. And we're going to close that and then hit return. And now we have integers. Look at that. Just at the click of a button, I rolled a die 500 times. Now I'm going to do the same thing over here. And I'm just going to do a second set of experiments. And instead of it being 500 times, I'm going to do it 5,000 times. So rand array is this function. Oh, and I said I was going to look at Excel help. So when you start typing a number, if you just click on the value that pops up, you actually get the help function for Excel. You could also find it through here. You can come in here to Excel help and then type in a number. Type in the value you want to find and then click on it. Now you'll note this is useful for when you know what it is you want to find. If you don't know, you could try typing in random words like rand, and they'll kind of pop up. Another interesting way to get it is Excel has a bunch of formulas up here, so you can go to financial, for instance, and see things. But at some point, like if you want to find a function in Excel for a particular task, just Google it, and it'll tell you what the right value is. Or if you're lucky, the Excel help will show right up. So coming back to this example here, we're going to roll the die here 5,000 times. One column, we're going to go between 1 and 6, and we want an integer. And boom, look at that. It's 5,000 times that I rolled the dice, okay? So now, real quickly then, I could create some charts. So I'll do the charts. I'll create the charts again in a minute, but let's just look at what we have. So I rolled the dice 500 times here. And I can just use an Excel function to calculate the average of these cells. And I can use Excel to calculate the average of 5,000 cells. I did the same thing. I used the variance function in Excel to calculate the variance. And I used the standard deviation to calculate the standard deviation. Remember where I said, like, it doesn't matter how these things are derived. This is what I'm trying to get at here is, look, we just did Monte Carlo simulation. We rolled the die 500 times and 5,000 times. We used the Excel functions to calculate the numbers. And I'm going to go ahead and hit function F9, which re-rolls the dice over and over and over again. And look at these numbers here. They're pretty much on the button. The mean is expected mean is 3.5. We actually have 3.46, 3.44. The variance is about the same, and the standard deviation is about the same. And the more numbers you do, the closer it is to actually the real value. Okay, so how did I create these charts? So I'll go ahead and create this one again and this one, the histogram. So this chart here, I just grabbed these, and then I went to Insert and Recommended Charts. And the first chart that it shows me is this right here. So I'm going to go ahead and add this chart back in. And then histogram. So I can take this, I can do my Command Shift down, select all those values. I'm going to scroll back up so I'm close to where the pictures were. I'm going to go back to Insert. I'm going to do my recommended chart. And here it doesn't show me the recommended chart, and I don't like either of these. So instead, I'm going to go into the histogram chart right here, select that chart, and boom, it creates it for you. Now, we're going to want to modify this chart, so I double-click on it, and we need to pick a data series here. And now, since we picked the numbers, we can come up here, to this, and I can change the bins, and I want to have 6 bins here. And now, all of a sudden, we have 6 bins. I'm going to back out all these changes real quick just because I had already created these charts and titled them nicely, so we're going to get that back. And what I want to show you here now with these charts is you can quickly chart things in Excel, which is nice. Using function F9, we can re-roll these things over and over again pretty quickly. And now I wanted to show you then that in terms of Excel generating a uniform distribution of numbers, you can see that, in fact, it does a pretty decent job of it. I couldn't tell you whether the random number generator in Excel is truly random, but that's a pretty decently flat distribution. Okay, so now I said we were going to use Monte Carlo to prove the central limit theorem. And we're going to talk about the central limit theorem in the next video. So I'll see you in a couple of minutes.